Okay, in this pre-quiz part 2 of chapter 5, let's go ahead and go through this. First question is the following a geometric sequence? That means you have to multiply by some number repeatedly to get all the other terms in the sequence. Okay, so if I start with 3 halves, I figure out what times that equals 5 halves. Well, if I can go in reverse and I take 5 halves and I divide that by 3 halves, that would tell me what I times by 3 halves to get to 5 halves. So multiplying, I multiply by the reciprocal, right? So I get 5/3. That means I should be multiplying each time by 5/3 in order to get to the next number in the sequence. So if I multiply this by 5/3, right, the 3's cancel out, I get 5/2. But if I multiply this one by 5/3, it should be repeated, right? But here, nothing cancels, so I get 25 sixths, which is not that one, right? So that's a no. Okay, then I do the same thing here. I have, let me switch colors. 1/9 divided by 1/3, and flip that. So 1/9 times 1/3, and if I multiply that, I get, oh, I gotta flip this. I didn't flip that, sorry. All right, so 3/1. Now I multiply and I get 1/3. So that means I'm multiplying 1/3 each time. So times by 1/3, I get 1/9. Times by 1/3, I get 1/27. Times by 1/3, I get 1/81. So this was a yes, because the common ratio is 1/3. Where this one, there was no R, no common ratio throughout. Okay, let's switch it one more time. Let's do blue. So this one, I'm going to take 48 divided by 96, and I'm going to see what that is. So 48 divided by 96, and I get 0.5. So that equals 0.5. So that means I'm going to try to times it by 0.5. I get 48 times that by 0.5. And I get 24 and times that by 0.5, and I get 12, right? So that would be yes as well. And the common ratio there would be 0.5. Okay. All right. So what is the explicit form of the sequence? If I have my A1, I have A sub n equals 4 times A sub n minus 1. This is a recursive formula. That means it gives me my A sub 1, my first term, and then it's times by the previous term. That's what A sub n minus 1 means. So that means my A sub 1 equals, oh, sorry, I already have my A sub 1. A sub 1 equals 5. Sorry, this is my common ratio. So that's R times that. Sorry about that. That is my recursive formula in general. So this 4 right here actually represents my R. Sorry about that. Now I want to write the explicit. Well, the explicit A sub n equals R A sub 1 times R raised to n minus 1. So I just plug in my A sub 1, which is 5. They give it to me. And then I plug in my R, which I find from my recursive. So that would be 4. And there's my formula. Okay, number 3 here. Okay, I want to find the explicit from this, so I basically want the same thing as the last problem. I want my A sub 1, and then I just want my R, right? And we find my R just like we did on problem number 1. 15 divided by the previous term, 3, equals 5, right? So then I know my R is 5, I know my A sub 1, now I can write my equation. I got my A sub 1 times my R raised to n minus 1. Done. Okay, next one. What's the recursive form for the sequence? Right, so here's the explicit, right, and that's this form up here that we did on number 2. Right, now we want on the recursive, which is right up here, right, that's the recursive. So I want for the recursive, all I need is my R, that's all I need. Well, my R is in the parenthesis right there, so R equals 2. So I'm just going to write AN equals my R, which is 2, times A n minus 1, or A sub n minus 1. All right, this A sub n minus 1 just represents the previous term. So that's it. That's all I have to do. Bam. Okay, number 5. Here we go. We're starting out at 1, and we're adding up all these terms until we get to 6, right? So long way I would plug in 1 into this, see what it is, plug in 2, plug in 3, plug in 4, plug in 5, plug in 6, and then add those all up, right? Faster way is to use the sum formula, right? A sub 1 minus A sub 1 times R raised to n all over 1 minus R, right? So that's the formula I'm going to use because I know what my R is. I know what my n is. My n is, it starts at 1 and goes to 6. So 1 to 6 is 6. Right, so 1, 2, 3, 4, 5, 6. That's 6 different numbers, so n is 6. Okay, and then my r is 2, and my a sub 1 is 1/9. Okay, so I'm just going to plug those into this formula and use my calculator, push enter. So a sub 1 is 1/9 minus, so minus a sub 1, 1/9. My r, I'm going to put my r in parentheses, which is 2, raised to n, which is 6, all over 1 minus my r, which is 2. Right, so I'm just going to enter that in and see what I get. Push enter and I get sum. So there is my sum. So I would say, how I'd say it for this problem would be S sub 6, because I'm adding up to 6 different terms here, equals 7. Okay, on this next one, we are finding A sub 1 when we have S sub n, and our R and our A sub 1. So it's a little bit different than this formula. What the formula I'm going to use for this one would be S sub n equals A1 minus A sub n times R all over 1 minus R. Okay, so a little bit different. Manipulate this a little bit. So, because I know my S sub n, right? So I know what that is. And then if I multiply by 1 minus R times S sub n, then I'll get rid of that denominator. So I'm times by 1 minus my R. And that equals A sub 1, which I want, minus A sub n times R. Well, A sub n, they give me is 120, right? So minus 120 times my R, which is 2/5 again. Okay, so then I can go back to solving this. 1 minus 2/5 would be 3/5, right? So I got 3/5 times 3,045. And then I'm just going to add this 120 times 2/5 over. And 120 times 2/5, I'm just going to do in my head. I'm just going to type all this 2/5, I said, not 3/5. So 2/5. Okay. And then I am going to, that will equal A sub 1. So let's enter this in the calculator and push enter and get what our A sub 1 is. Okay, and we get 1,875. So that's our first term in sequence. And then we can tell it's times by 2/5, so it is decreasing in order. So then when we add it up, it's going to be more than probably what we started with, right? Okay, next one. Again, we want to find A sub 1, but this time we're given an R and an N. So I'm going to use this formula right up here for number 5 that we kind of used. We're just going to rework it, right? So I know S sub n, negative 728. And then we don't know A sub 1. But this A sub 1's times by R, which we do know is 3, and that's being raised to n, which is 6, over 1 minus R. So that's a multiplication dot there. Okay, so now if I simplify this, the bottom would be 1 minus 3, which is negative 2. So we're going to actually multiply both sides by negative 2. So we're going to multiply both sides by negative 2. So negative 728 times 2, or negative 2. We get 1456. And then 3 to the 6th, which I can't remember off the top of my head, 729. 729 is going to be times by A sub 1. So this is really 1 A sub 1 minus 729 A sub 1s. So really, this is just negative 728 times A sub 1. Because really, this is just like 1x minus 3x or something like that, right? So we can just divide it. We can see what it's going to be. And that's just A sub 1. I don't need that right there, sorry about that. a sub 1 equals -2, right? So that means we're just multiplying. We're starting out at -2, and then we're multiplying by 3, right? So there's our answer for that. Okay, so here we have a customer. Here we have Sandra, and she just started a job with an annual salary of $3,000 each year. Her salary increased by 6%. If Sandra continues to work at this job, what will be her total earnings in the first 5 years? Round to the nearest dollar. So we know in her first year, her annual salary is $30,000. Okay, so then in her $30,000, in her second year, she's going to make 6% more, right? So we know we're just multiplying by 0.06. So 30,000 times 0.06. And that's 1,800. That doesn't mean she makes 1,800. It would be the total, right? So I really want these numbers to be my totals. So I'm going to add that to the previous total, right? So 3,000. So it's going to be 3,100 or 31,800. If I can say it right. There we go. Okay. Now the next year, right, she's going to make 6% of that last year's total, right? So we got to times that by 0.06 and then add it back to this total. Okay, so it's kind of like that air balloon a little bit that you did on McGraw-Hill. Okay, so we'll times that by 0.06 and then we'll add that to this original total. So that increase of 6% is 1,908, but then I got to add it to my year 2 total, right? So I got to add it to my year 2 total, 31,800. So that's 33. Now there is a quicker way to do this. You can come up with the formula, explicit formula that you can plug in 5, right? That you would get this. So there could be a faster way, but you can just do it by hand, just like this. So I'm going to take this number right here and times it by 0.06, and that's 2,022.48. But I'm going to add it back to this original one, right? This 33,708. So I got to add that to it. So we get 35,730.48. Then I'm going to do it one more time. I'm going to multiply that by 0.06, and then I'm going to add it back to that total of the 4th year. And so then I get in the 5th year my answer of $37,874 and round to the nearest cent. So that would be 31 cents. There you go. Okay. This one, we haven't done it yet. It's in 5.5. We will do it. So how I enter this data in, we've kind of did it before though, stat. And I hit the stat button. And then I hit enter on edit. And now I have a L1, and L2. And then if I want to clear it, I go up and highlight L1 and hit clear. And then hit enter, and then highlight L2 and hit clear and hit enter. And then I can put these numbers in here, okay? So I want to hit 1, enter, 2, enter, 3, 4, 5, 6, and 7, enter. And then I want to move over to L2, and I'll put these numbers in L2. Okay, so 8.71, enter, 20.03, enter, 46.07, enter, 115.118, enter, and then 198.61, enter, 198.61, good, 362.54, and 725.08. Okay, so once that's in there, then I want to hit stat again, stat, and I want to move over to calculate, and then I want to go down, and since we're in exponentials, we're kind of just going to jump down to 0. We're going to go down to 0 where it says exponential regression. We're going to hit enter. And we're going to make sure our X list says L1. If it doesn't say L1, you can just hit second 1. And then Y list is L2. So I'm going to hit second L2. I don't care about frequency. Who cares about stored regression right now? and then go to calculate and hit enter, and it will calculate what your equation is. So your equation is listed as y equals a times b raised to x. So we're going to write our equation as our a. I want to round to the hundredths place. So y equals 4.81, parenthesis, now I want to put my r in, 2.08 raised to x. And that would be my equation that estimates. I can now do predictions. I could put in 9 and see what it comes out to. I could put in 4.5 and see what happens in between here. So that's my estimate equation. That's my equation that I can estimate. Okay. And then the same thing here with population. So I'm going to do the same thing with population. I'm going to round to the nearest whole number in the very end. Okay, so I'm going to make this be my L1, make this be my L2. So I'm going to go back to stat, enter, edit, and change these numbers to, I could really do, probably in 2011, I could just do 1, 2, 3, 4, 5, 6. So then I can just really just delete my 7th one from the last problem. Just highlight it and push delete. And then I can plug all these numbers in here for my L2s. So 55, 5250, make sure you get it right. 5250, 5510, 5790, 6080, 6380. It won't work, your regression equation won't work if you have a different number of x's than you do y's. So that's how you can tell if it doesn't, it says error, you want to check that first. Make sure those numbers same, and then put stat, hit stat, move over to calculate, go down to 0. And why we're doing 0 is because that's the chapter that we're kind of in. Make sure your X list and Y list are Y1, L1, and L2. Go down to calculate, hit enter, and it'll tell you what your equation is. So here's my equation, my A, which this A that they give you, this A right here, Y equals A, B raised to X, like that. That A is actually your L1, and this B is actually your R. Okay, and that's kind of the equation that they're giving you. We're used to kind of this -1 on there. They're not really worried about that. Okay, so 4,999.77, and our R is 1.05 raised to x, and that's the equation that I write. So you can check this. Some of your calculators are on this. Sometimes you might see when you do this and hit calculate, you'll have an R at the bottom. When R is close to 1, which we've talked about before, the closer it is to 1, the more accurate it is. So we could do like a linear regression, or quadratic regression, or quintic regression, and see which one's closest to 1. Whichever one's closest to 1, that's the one we usually go with. But still, we still want to do predictions inside. So now if I want to find what's happened in 2018, I can use this equation to predict that. But I really don't want to go too far out 2018. I want to predict like 2050 or something. Okay, that's kind of extrapolation. That goes outside our data too far. But I can do 2008. And so since I labeled these 1, 2, 3, 4, 5, 6, I really just want to put an 8 into this equation. So I can go ahead and just put an 8 into this equation and hit enter. So 2 ways to do it. I could just I can clear my calculator and just type this in, 4,999.77, parenthesis, 1.05, parenthesis, and raised to the 8th power. Now, if you left the 2011 and that in, you'd want to do 2018. But since I didn't, I'm just going to use 8. And hit enter, and then I can predict what is this population is in millions, I think. Probably, maybe not. All right, so the population would be 7,387, round to the nearest whole person, right? So 7,387 would be the population. Okay, so you can do that once you have your equation. You could store this equation in y equals, and then you could use your table and go down to number 8, but this is probably the quickest way. Just enter this back into your calculator and just round these to the hundredths place. All right, that is for the pre-quiz.